Hi, I'm gonna explain the quiz 2 from week 1 of physics 2. The problem says like this. If the air density were uniform, how high would the atmosphere be? And if it decreases linearly to zero with height, take the air pressure at the level to be 1 atmosphere and the air density equal to 1.3 kilograms per meter cube. Okay? Now, for solving the first question, that is if the density is uniform, I'll draw here the air. This is the air. This is air, and this is the end of the atmosphere. Okay? If we take into account that here we are starting at 0 height, and here we are looking to an h height, here we have the density of air, that is this one, and we also have pressures. Here my pressure 1 will be always in the 0. It will be as to say at sea level, so it will be 1 atmosphere, that equals to 1.013 times 10 elevated to the 5th pascals. Okay, and here we'll have that our pressure 2 will be 0 because at the end of the atmosphere there's no pressure at all. Okay, now for solving the first exercise, we'll have our formula for pressures, that it's P1 minus P2, these are the pressures, that equals rho G, gravity, density, gravity, and my height. Okay? So, as we can see, our pressure 2 equals to 0. So, we'll take this one out. And now we have to guess this part. So, if we take out the y's to this side and the pressure 1, we put it inside, we'll have something like this. y2 minus y1 equals to the pressure 1 over these two values, that it's the density and the gravity. Okay, as we can see here, our y1 it's equal to 0 because it's at the sea level, so we're starting from there. So here this one will be 0. Okay, so now we have this value to guess, and here we have that the pressure 1 it's 1.013 per 10 times elevated to the 5th pascal over our density, that it says here 1.3 kilograms meter cube, times the gravity 9.81. And as we solve this, we can get that the value of y2 it's equal to 7.9 per 10 divided 3rd meters, that it's equal to 7 kilometers. Okay, now we have here the first part. For the second part, that it says that if the density decreases linearly to 0 with height, we have to integrate our formula. So we'll have here from 0 to h because it changes. Okay, so here we'll have the density, gravity, y2 minus y1, okay? As we can see here, the integral will have to take into account the density that it's the one that changes. So here I'm gonna write that the density will be equal to the density of the beginning times 1 minus YH, that this is the height of all the air here. So here we have the y corresponds to an area that is from 0 to h. Okay, once we know where y belongs, we can have here two functions for knowing the densities of the 2 points in the atmosphere. So here the density when y equals to 0 will be equal to our density of the beginning. And we'll have here that the density when the y belongs to h, that is my highest value here, this will be increased into 0. Okay? Now, by using these two functions, we can integrate our equation here, and we'll have that P1, well, no, P2, because we'll leave P2 out. P2 will be equal to our pressure 1 and we'll put in the integral of this part. So here we have the integral of this value that I wrote here times 1 minus g over h, g times g, and our dy. And this, as we integrate it, we will have that pressure 2 will be equal to pressure 1, that it's a constant, and the integration of this first with 0 will be that it's minus the density of the beginning times the gravity times y. This part here belongs to the density, gravity, and the height. That is the main part of the equation, the formula. And this will add the density of the beginning times the gravity over the height times y squared over 2 from 0 to h. Okay? And this part here belongs to the density of the beginning times the gravity over the h squared, and this over 2h. Okay? Once we have our integral, we can sum this, and we'll have a new formula. The new formula states that the pressure 2, it's equal to 1/2 of, well, no, we'll start with the pressure. Pressure 1 minus 1/2 of our density for the beginning times gravity times the height, and using this equation, Now we can substitute the values in here, but as we can see, pressure 2 it's equal to 0, as it says here. So by discarding the pressure 2, we'll have to get out the height that is the value that we are looking for. So as pressure 2 equals to 0, we take out the h, and we'll have that h equals to 2 times the pressure 1 over the beginning density times the gravity. If we substitute the values here, we'll have that 2 times the pressure 1, that is 1.013 times 10 elevated 5, over the initial density, that the initial density it's the same as in the first problem, it's 1.3. This times the gravity, 9.81. As we solve this operation, we'll have the height will have value of 16 per 10 cube meters, and this is the height when the density starts to lower until it gets to 0.